everybody. So for the asynchronous day for tomorrow, we are going to start with lesson 10.1 as I discussed today in class and showed you. We're going to do this over 2 days. So I'm just going to do a part of this packet, just follow along, and then you can fill in the notes. I also have the filled in notes posted online on the calendar, as I always do, and then the answer to the worksheet. So let's do that. 10.1, we're talking about arcs and sectors. This is a warm-up of the circles that we did yesterday, so we just skip it. We can work on it in class tomorrow. And I'm going to skip the explore and reason. And then, again, I'm in 10.1, arcs and sectors. I'm going to flip, and we will start here by identifying different parts of a circle, since we're talking about circles. Okay. So the definition of a circle, the mathematical definition of a circle, is the set of all points in a plane that are equidistant from a given point called the center of the circle. So that means you have the center of the circle. It's the set of all points that are the same distance away from this point. That's the definition of the circle. So think of a compass where you draw a circle. All the points are the same distance away from the center, basically. Okay, so let's identify the different parts. A segment whose endpoints are the center and any point on the circle is a radius. And we will color code it here. This one is the radius. It's written here, but it's faded. The printing wasn't great on that. Okay, so that is the radius. Okay, and then a chord. The next one is a chord. Is a segment whose endpoints are on the circle. So this is a chord. We got an endpoint here right on the circle. So that's the chord. Okay. A diameter, as you know, is a chord, it's a major chord, that contains the center of the circle. So the diameter in this picture looks like it's this one. Okay. A secant, the next one is a secant, is a line that intersects a circle in 2 points. Okay, it intersects the circle in 2 points. Here's the 2 points, and that's a secant. It intersects it in 2 points. See? That's a secant. Okay. And then the next one is a tangent. A tangent is a line in the plane of a circle that intersects the circle in exactly 1 point called the point of tangency. And it is perpendicular to the radius always. Stay tuned for that. We will come back to that in future lessons. Okay, the tangent is always perpendicular to the radius, and then if I go up in the picture, this would be the tangent. See how it's intersecting the circle? It's exactly 1 point, so it touches the circle basically. That's a tangent. And that's another radius here. And then you can see it's perpendicular to the radius. All right, so pause the video and see if you can identify these different parts, label them as, what are they in the circle. All right. Tell whether the line segment is best described as a chord, secant, tangent, diameter, or radius of a circle C. Okay, hopefully you pause the video and you did this on your own, and then now you're checking. This one is a diameter. Okay, CD is a radius. EG is a line, EG is a tangent. segment HB is a chord, and line GK is a secant. All right? Okay, more definitions. All right, a central angle of a circle is an angle formed by two radii whose vertex is the center of the circle. Okay, namely, this is the central angle. This is the vertex of the angle. It's right at the center of the circle, and that's a central angle. So this is the central, called a central angle. Okay, a central angle divides a circle into two arcs. An intercepted arc is the part of the circle that lies between two segments, rays or lines that intersect the circle. Okay, so central angle divides the circle into two arcs. So namely here we got two different arcs. We got this arc and we got this big arc. The intercepted arc is this. It's intercepted by this central angle, see? This is intercepted arc. Okay? And the piece of information here that also we will see again and again, a central angle and its intercepted arc have equal measures. Have equal measures, okay? So the measure of the arc in degrees is the same as the measure of this angle, of course, in degrees, okay? All right, minor arc. So I'm going to go with the notation. So let's define a minor arc, a major arc, and a semicircle. And for the notation, I'm just going to use this picture down here below because it's already like it has the letters and everything, okay? So the picture is below for the notation. So, and that goes with this too, with this labeling, okay? So if I put them all on one screen, okay? So if measurement of angle APB is less than 180 degrees, okay, then the points on circle P that lie in the interior of angle ABP form what's called a minor arc with endpoints A and B. Okay, so in this picture, this is the minor arc. Okay, and then in the notation, we use two letters to represent a minor arc, and we make like an arc sign like that, and then two letters. So for this arc, it's AB, or you could go BA. It doesn't matter. The order doesn't matter. It's just two letters. It's a minor arc. Okay? The major arc, the points on circle P that do not lie on a minor arc, on minor arc AB, basically form a major arc. With endpoints AB. So it's still endpoints AB here, but if you notice, the major arc, for the notation to distinguish between the two, we're going to use three letters for the major arc. Okay, so we're going to incorporate the C with it. So we're going to name it, we're going to make an arc sign like this, and then ACB or BCA, doesn't matter. Or arc BCA. Okay, so major arc, minor arc, and then this one, of course, measures this is greater than 180 degrees. Major is greater than 180, minor is less than 180. And semicircle is exactly 180 degrees. An arc with endpoints that are the endpoints of a diameter. Okay, that's a semicircle. They measure exactly 180 degrees, and we use three letters for the notation here. Okay, and then there's no D here, so I'm going to make a D. I'm going to make a diameter, okay? So let's make this point be D, and then now the semicircle is DCB here, or it could be DAB as well. DAB, DCB, they're both semicircles. All right, let's do the example 1. Now we can apply all this information. What are the measures? Notice, just like angle, we say measurement of angle. Here we say measurement of arc. So M, little m, indicates measure. What is the measure of arc AB and the measure of arc ACB in this picture? Well, we know from above here, the central angle and the intercepted arc have the equal measures. So measurement of arc AB equals, it's the same as the measurement of angle APB, which is 95 degrees as indicated in the picture. Now, what is a measurement of a full circle, full rotation? That's 360. Okay, so to get the measurement of arc ACB, this other part, you just take full revolution of a circle, 360, and subtract the 95. And then you get 265 degrees. All right? Let's flip the picture. Okay, here's the try it. So pause the video and see if you can do the try it. Oops, over here. And the try it on your own, and then check your answer. Okay? All right, arc MN here is a minor arc, and it measures 80 degrees. PMN is a semicircle, and it measures 180 degrees. Okay, measurement of PM, that's going to be 180 minus 80. So it's 100 degrees, and it's a minor arc. This one is a major arc because I got 3 letters. MPN, this one. It's 360 minus 80, which is 280 degrees. All right, more. Find the measure of each arc of circle R. You know, let's make this, I'm going to find this angle here, GRF. So take 360, subtract 110, 80, and 40, and then we're going to label it 130 because we're going to need that here in a bit. Okay, now I have all the different angle measures here. All right, measurement of GE, that's a minor arc. GE is going to be 40 plus 80, which is 120 degrees. Okay, GEF, that's 40 plus 80 plus 110. That's a major arc. Okay, 230 degrees. Okay, measurement of arc GF. GF is 130 degrees. I already calculated that. Take 360 minus all of these, 110, 80, and 40. And then measurement of E, this one is a minor. This one is a major. EFG, so EFG, this big one. It's going to be 360 minus, okay, EFG, so 360 minus 110 minus 130, or I don't know why I did it the wrong way like that. Just do 110 plus 130. That works too. It's 240 degrees. All right. All right, I'm going to pause this video and then make another video, video 2, because I don't want it to be too long and I want to make sure it works when you play it. So that's a 14-minute video. I'll start here on the next video. Please watch both of them. And I'll try to go as fast as I can and as short as I can have the video, okay? So stay tuned. One more video.